Alright, so let's go ahead and build a Fibonacci circuit so we can close out our shift register. And I've already defined an adder circuit, so I'm just going to load that into here. I'm going to say new library, and I'm going to go to a library of cells called adder. And in there I'm just going to add this basic adder, sum to the north. So there's a block that takes in bits from the north and the south, adds them together, generates a sum to the north, takes a carry in from the west and generates a carry out to the west. So we can cascade these in a horizontal line, feed bits in the bottom and top, and generate the sum out of the top. And we're going to be able to use that as part of our Fibonacci circuit. So I'm going to move my useful cells over there. I'm just going to close out my Java simulator for now. And move this out of the way, and I'm going to open a new grid. So I'm going to make this a 32 by 32, and I'm going to close out my shift register grid. And so how am I going to build a Fibonacci circuit? Well, I'm going to basically use two of these shift registers. I'm going to use one to hold each of my two numbers that I'm currently adding. I'm going to take the outputs of them and feed them into an adder block, and the output of the adder will feed the input of the first shift register. The output of the first shift register will feed the input of the second shift register, and the result will be something like is shown in the video that corresponds to this demo. But it will be two shift registers holding the two numbers that are currently being added. The first number will shift into the second, and the sum will shift into the first, so that each time we tick the clock, we will have two new numbers plus their sum, which should be the next Fibonacci number. So how are we going to do this? Well, we're going to start off with a shift register block. So I'm going to copy this with a Control C, paste it with a Control V, and I'm going to put these small hats on the top and the bottom. So going to paste this over here and rotate it into place, paste this one over here and rotate that into place. And I'm going to take these three and I'm going to do a Control G, which is a region shift. So instead of region rotate, so instead of rotating each cell, I rotate this collection of cells and it turns the whole block sideways. This is going to be my entity that holds a single bit, and I'll put it down here to make some space. Now if I copy these and then just select a region of cells over to cell 23 and paste, it will fill that up. And so these are going to be the 8 bits of my first number that I am going to use in my Fibonacci series generation. Now I'm going to make another copy of this down here, and I'm going to put this down 8 spots, and I think that will be a good place for it. And what I'm going to have to do is, let's pull this over here a little bit. What I'm going to have to do is put my adder over here, send the outputs of this into the top of the adder, send the outputs of this register into the bottom of the adder, take the sum and send that back in to the top of the whole shebang. So I'm going to need some bits of an adder, so I'll select that over there, and I can lay these out pretty much anywhere that I want. It doesn't really matter, but I'm just going to put it right down here. So there's the 8 bits of my adder, and now I'm going to do a bunch of routing. We're going to build a bunch of wires. I need to feed these 8 bits into the top of this block of adders, and this will look laborious, but it will actually go pretty quickly once we get the techniques down. So I'm going to take this cell, copy it, paste it right here, rotate it into place, and I'm going to do this. No, I'm going to put it up here, and I'm going to lay these out in a diagonal. And I'm going to take this cell, copy it, and I'm just going to fill up these with copies of this cell that copies from north to south. And now I'm going to feed the outputs from each of these values into each of these lines. So I need another corner cell that's going to tap into each of these outputs. And I'm going to feed those where appropriate. So it's really just a bunch of pointing and clicking and pasting, and this is where keyboard shortcuts really help, because if you have to move up to the menu every time you want to copy or paste, you're going to lose your rhythm. So I'm just pasting all of these, and once this is done, you'll see what we've got pretty easily. This is also where a monitor with a lot of pixels can help. I've got 1900 pixels across on this screen, and that helps more than the size of the monitor. It's the number of pixels. So now the output of my shift register comes out of these 8 cells, and I'm just routing them directly into the top of my adder block. So that will make this the first number that's being added by this collection of blocks. I don't need to do anything with the carries. The initial carry will be a 0 because there's nothing over here to the right of the cell, and the carry out from this stage gets fed to the carry in over here, and it just ripples across. We're clocking this whole thing, so we don't really care about the speed that we're spending doing a ripple carry. Now I need to feed the bottom of this, so I'm going to build another collection of wires like this, and I'm going to come out of the output of this cell, and same deal, I'm just going to place these, and you can start to see why a place and route tool will be a very nice thing to have, because so much of this is laborious, just making wires just to build connections from one section to another, and especially when you're trying to run buses. If you're trying to run a long bus, you can paste a whole bunch of areas together, but for corners and things like that, it ends up being quicker just to do it sort of one line at a time. So here I pasted the last cell that I was working with, and it was facing the wrong direction for what I want to do here, but that's no problem. I can just hit Control R 3 times, do a Control C to recopy it, and now I can continue pasting. So very fast, even though there's a lot of manual labor here, it goes really quickly once you get down the keystrokes, and I just permanently have my left hand on the control and the V, and my right hand is just positioning the cursor. So now this bit is feeding into this one, and these other bits need to feed into the other positions, and they're all set, but this bit, for example, comes out here, but it doesn't go anywhere, so we need to get from the output on the north of this cell into the input on the south of this one. So here we're going to use that OR paste again. So I'm going to take this cell, rotate it twice with a Control R, copy it with Control C, and now I'm going to come here and I'm going to do Control Z for an OR paste, and that's going to combine the truth tables for these cells in a logical way that if the icons are drawn following this kind of standard convention, the combined icons end up looking exactly like what you expect them to be. So I'm going to Control S to save this at this point because we've done a lot of work, and I'm going to save it as just fib.grid, which alliterates nicely. So there's my Fibonacci generator, and so far we have 2 registers holding 2 8-bit numbers. They're both being fed into an adder. We need to take the output of this adder and send it into the north of this register. So we've got 3 rows of cells up here. We're going to need 8 to do all of the routing, and we have more than that down here on the bottom. We have 11 cells left. So I'm going to grab this whole area, I'm going to Control Exit, and this is where it's good that I saved it already, and I'm going to come down here to 8, 0, that'll leave us a little space at the top, and I'm going to paste, and we can always check and make sure that we didn't lop anything off the bottom. And I think this will give us enough room to move around on the top. If we need more room, we can just select everything, cut it, move down, paste it again. So nothing is too precious. So I'm going to need to come out of the sum bits of these. And so here I'm just going to copy this, and I'm going to do an OR paste through this whole region with a big Control Z. And now I've got my output bits coming out of my adder, and they're ready to send over to the inputs of this shift register stage. So we'll make some more corner wires here. So this will feed my first bit, and there's a reason I'm doing it in this order that we'll see in a few minutes. And did I get it right? Yes, I did. Alright, so this is feeding the inputs. I'm going to rotate 3 times, copy, and start pasting my wires. And it's probably better if you do this after you've drawn the things that it's going to connect to, but if we're off by one or another, it's just a little more editing we're going to have to do. It's not the end of the world. So now this is my least significant bit, and I need to send that into this stage of my adder. So I just need another one of these taps. So I think I can just put these right here, and then copy this and start filling in all of these cells. And there, we're almost done. We need one more thing. We need to take this bit that's come out of the adder and we need to actually bring it down into the input of this shift register. So I'll grab our favorite straight line wire, copy it, and I'll do some more OR pastes with some Control Z's and bring that into the top of the shift register. Very manually intensive process, but it's really not as bad as you would think when you consider that you're basically laying out cells one cell at a time. We got this whole circuit together with a fair amount of routing pretty quickly. Obviously not as fast as writing in Verilog and just saying go, but really not too bad. So now our circuit's looking pretty complete. Shift register here, output goes into the top of the adder, output of this goes into the bottom of the adder, and the result goes back in. Now the next thing we need to do is we need to feed the output of this shift register into the input of this shift register, so when we clock a shift register, the result of the addition will get loaded into here, and the previous value here will get loaded into here, and the previous value here will be lost. So this will be, for example, 3 and 5 will generate a sum of 8. We'll have 8 going in here. When we shift, 8 will load in here, 5 will load in here, 5 plus 8 will be 13. Coming up to the top, when we shift again, 13 will go in here, 8 will go in here, and so on. So we need to take the outputs of this and feed it into the inputs of this shift register. So take our north-south wire, and we're going to do another OR paste on here. And you want to be careful. If you OR paste on top of this cell, you'll get a warning saying that you've got two cells that are both driving the same output. Now it won't cause any problems, but it will give you warnings which you don't want to ignore, because if you really do overlap two cells with the same output being driven, that will be a problem. So make sure that you're only pasting on the part of it that that we actually need to change. So, and again, I'm just doing this with Control Z, which is the shortcut for OR paste. And I'm going to save this again because we've done a lot more work, and this is looking pretty good. So we need to do at least one more thing, which is we need to drive the clock on these shift registers. Now a different shift register design might work better. We could actually feed the clock from one stage to another, but I wanted to use that shift register that we built in the previous lectures. So I'm going to send a signal to the clock, and I'm going to use this cell here, and the clock comes in on, in this case, the southern part of the middle part of each shift register. So I'm just going to paste these taps into here, and I'm going to run a wire to connect them. And in this case, I'm just going to OR paste across all of these. And by doing that, I'll have a wire that's moving all the way across this row of cells, but is also being tapped into by each of these corner pieces to feed the clock line. So there's my whole clocking circuit, and I'm going to copy everything that I've selected there and just do a regular paste down here to get the same thing. And that looks pretty good. We still need to add this corner back here, but I didn't want to just copy this cell. So I could go over here and grab this cell, or if I wanted, I could just come up here and I could say explode composite cell and copy my cell from here. So do a Control C, close this, go in here, do a Control Z to OR paste, save it again, and now we've got two clock lines feeding into our shift register. Now we want to feed these from a single clock line, so I'm going to take this cell and I'm going to say my clock comes in on cell 00 from the north. I'm going to OR paste it through there, and what I'm going to do is put another tap over here. So let's take this cell, copy it, and OR paste it. Let's just regular paste it in here. So So now I can feed a clock line from the top of this cell, and that will drive the clock input on all of these stages of the shift register. I'm going to take the same cell and put that down here, and now I'm going to take this north to south arrow and I'm going to OR paste it through all of these. So now a single input on this cell will drive this set of clock inputs and this set of clock inputs, and that should shift the whole thing. So I can save this and I can load it into the simulator. Oh, I need to bring this all the way up to the top. So copy and paste and save it again. I'm saving with Control S. And that should work with one small complication, which is when you load this into your system, initially all these shift registers will have a value of 0, and we won't actually observe anything happening, because if you start your Fibonacci series with 2 zeros, you don't get anywhere. So I'm going to do something kind of tricky here. What I'm going to do is put in a special case in the beginning. I'm going to look at all the bits coming out of my adder, and if they're equal to 0, I'm going to feed a 1 into this least significant bit of this register. So this will seed my Fibonacci series with the two numbers 0, 1. Those will get added to 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, and so on. So I need to take these 8 lines and I need to OR them and figure out if the result is a 0 or not. So the way I'm going to do that is as follows. And let's see, there's a few ways to go about doing this. The trick is finding a good place to put this in without necessarily making our circuit too much larger in size. So I'm going to build an OR gate like this. So I'm going to come over here, and I have a couple of OR gates in my palette of useful cells, and I want to OR these together. So I'm going to take what's coming in from the east and OR it with what's coming in from the south. So east, south. Let's see if this will do it. This should do it. So I'm going to copy this and I'm going to OR paste it on here and on all of these. So now the bit coming in from the east, which is the bit coming out of the adder, is being ORed with whatever's coming from the south. So this is basically making a big multi-input OR gate. It's coming in with an initial value of 0 because there's nothing coming out of this cell here. So the top of this will be the OR of all of these 7 inputs, and I also need to OR it with the least significant bit, which is up here. So I'm going to take a wire and use that to tap into here. So I'm going to do an OR paste there, and I'm going to build one more OR gate. So I'm going to take what's coming from the south and the east and OR it, and I want to send it this time out to the west. So I'm going to use this cell, rotate it, copy, paste it, and now the output of this will be the OR of all 8 bits of my adder's value. I'm going to invert that. So here's an inverter. And then I'm going to take that and I want to send it back down here. Well, let's see. I'm going to make this easy. I'm just going to go ahead and do a Control A to select everything. I'm going to do an X to delete it, and I'm going to paste it right here. I haven't chopped anything off on the bottom. I'll extend my clock input up here. And now I have my 8 bits ORed together. It's inverted out here, and this will tell me what the least significant bit should be. In other words, if this output is a 1, I want my least significant bit to be a 1. Otherwise, I'll just leave my least significant bit to be a 0. So I'm going to use this as follows. Okay, actually I don't need that extra space at the top, so I can do some Control U's to undo the last few changes. Brings me back to where I was. That can be a little scary if you haven't saved. But I'm going to take the output from this and I'm going to bring it back around into one of these cells here, and I'm going to OR what's coming in from the north with what's coming in from the west. What's coming from the north is the actual least significant bit. and if that's a 0 but the output of this is a 1, then this will be a 1 coming down to the bottom. What you don't want to do is modify the bit over here, because you'll end up with a loop where you're changing the input to the logic gate, and you'll end up with an unstable grid that'll oscillate. So I'm just going to take this output and I'm going to wrap it around and bring it into here, and I'm going to pick one of these cells. I'm just going to pick on this one, and I'm just going to delete that for now, and I'm going to replace it with an OR gate. That's going to take what's coming in from the north and the west and OR it and send that out to the south. So I'm going to copy this and paste it here, and now I'm going to copy this and OR paste it on top of there to restore what I originally had. So I still have this third bit going through and getting OR here and coming into the third bit of the shift register, but I also have the option to send a value into here and use that to conditionally set this least significant bit. So now I just need to bring this inverter's output and bring it around to here. So that's just a bit of wire. And once you have a big circuit, you usually don't need to keep going back to your palette of cells. You can usually find the cell that you want, or a rotated version of it. So I'm going to copy this, paste it here. I'm going to grab my corner and paste it here. I'm going to take this, paste it here, rotate it, copy it again, do some, well, I don't need any OR pastes. I'm just going to take this, and I can't OR paste it here because it's in the wrong orientation, so I'm just going to paste it over here, rotate it to the way I want it, do an X to cut it, and then do a Control Z to OR paste it. And now I just need to bring that over here. Here's a good handy wire. I can paste that and OR paste like this, and I should be all set. So now if the output of my adder is all zeros, I'll have a 1 coming back here, and the bit going into here will actually be a 1. That should seed my two pairs of registers, and so this is our first version. Let's save it. Let's write the binary grid and make sure that that this works. So I'm going to write fib.bin, and we should be good to go. So let's pull this out of the, oh, we need one more thing in here though. We need to actually see what the output value is. So I'm going to take the bits that are coming out of well, let's take the bits coming out of the adder and display those on the west side. So I am going to move this whole thing down. So I'm going to save it with Control S, select all with a Control A, cut it with Control X, click here, do a Control V to paste. Bottom is still fine. And I'm just going to pull these bits that are coming out of the adder and extend them over here to the west. So let's extend the clock input first of all. Let's take one of these and let's do some OR paste. So we'll OR paste on there and there, and this will give us our 8 output bits with one exception. Remember, we used this row to take the bit that was coming from the least significant bit and combine it with the OR and generate this feedback. So we don't want to send this bit out. So let's build a line of cells here to read the output. But let's take one of these lines here and let's just tap into it. So I'm going to use this kind of tap and paste that right here with a Z, and then take one of these and paste that, build some wires to come over here. Already grab an arrow, build some wires over here, so Control V, and then copy V, rotate that into position, and then I need that other corner, so copy that, Control V, rotate that into position, Control S to save. That should give us our 8 bits coming out of our adder, least significant bit on the north, very close to where our clock is activated. So this should be a fairly easy circuit to look at. So I've saved the grid. I'm going to write binary grid, and I'm still going to write fib.bin, replace it, and now I'm going to run my simulator. So I'm going to do Java Sim, and I'm going to bring up my window, and most of the action we care about is going to be right here on the left, so we don't need a real big display. I'm going to say load 00 fib.bin, and you can see it loads in. And if we scroll over, we should see a bit being set to 1, which I don't see. So we may have made a mistake, but that's okay because we will debug it. Let's see what happens if we just hit the clock a few times.